document.body append child to render.dom element. Render.dom element. Element was capitalized. Okay. So setting up the scene, the camera, and the render. There are a few different cameras and 3 perspective camera. Attribute is the field of view. Okay, cool. That's the 75. Extent of the screen, extent of the scene is displayed on screen at any given moment. Value is in degrees. Second one's aspect ratio. Almost always want to use the width of the element divided by the height. Probably get the same result as play all moves in widescreen, so like a letterbox kind of thing going on. The next 2 elements are the near and far clipping plane, which means objects further away than the camera won't be rendered. You won't have to worry about this now, but you may want to use it for performance. Next one is the renderer. The magic happens. WebGL renderer we use here. 3.js comes up. Flash. Often used as fallbacks for users with older browsers or those who don't have WebGL support. Additionally, when creating a render instance, we also set the size of which one to render the app. Okay, switch to send. That's at least render and add to the document. Canvas element render uses display scene to us. Where's that QB promise? Let's add it now. So var geometry. Okay. Let's do this. I'm gonna freaking switch back and forth between this all the time. Perfect. Okay, so var geometry equals new 3.box geometry. Geometry, Geometry. Var material. Oh, interesting. Equals, so var mat equals new mesh basic. That's interesting. Color 0x00 ff00. It's red, I believe. Red, no, it's green. Red, green, blue. And var cube equals new 3.mesh geometry material or mat. That should be geom. Scene.add cube. Camera or cam.position.z equals 5. Okay, so to create a cube, need to so we create a box geometry. With this, we create an object that contains all the points and vertices and fills for the cube. It's more in the future. In addition to the geometry, we need a material to color it. So we're just using a color to color it. Hex color it. As a mesh object takes geometry and applies it to the material, applies material to it, which can then insert into a scene, further move around. Default, when we call scene.add, thing we're adding will be added to the coordinates at add 000. This would cause both the camera and the cube to be inside each other. To avoid this, we simply move the camera out a bit with the Z5. Okay. Rendering the scene. If you copy the HTML I created earlier, you won't be able to see anything because we're not actually rendering anything yet. So that we need to call the renderer animate loop. So function animate. Quest animation frame animate render dot render scene camera. It should be cam, not camera. create a loop that causes the render to draw every time the screen's refreshed, so every 60 seconds. If you're writing games in the browser, you might say, why don't we just create a set interval? Thing is, we could, but request animation firm has a number of advantages. Importantly, so that pauses when the user navigates to another browser tab. Okay, so interesting. Animating the cube. Let's go ahead and start with this first. So, save that. Projects, yes. Websites, the games, revamp, and then index.html. Yes. Now, FileZilla. See if I can remember. I think I have it automatically set up to connect to my website. Yeah, there we go. So, I'm going to create a new folder. New directory, call it revamp. And we're going to throw everything into here as we're working on it. Alright, do I have access to... Can I even get to a network location here from this? That's a good question. Should be able to. Yeah, there we go. Okay, so if I wanted to test this now, should be able to come over to here and go to games.com, revamp, index.html. Yeah, awesome. Three is not defined. Oh, I bet it's because we have to do something different. Let me just combine the two together. And see what happens. So I don't see that constructor 17. Okay, so we'll need to do this a bit differently, I think. Or let me interesting. So according to this, Internet Explorer does not support import whatsoever. Edge does, though. Chrome does. Everything except for Internet Explorer does. Full support. So import. Okay, so import star means import everything from wherever we want to pull it in from. These import statements. Const might not be the right thing to use for that. There also be an issue with this actually working that way. Import blank as blank from. Let's see then. If that is right, then we need to figure out why it's not pulling the. Not local files. Interesting. Maybe it has to be let. Whoops. That's not JavaScript. Okay. Are you kidding me? Dreamweaver, stop being a dork. Okay. There's not defined at 21. So, module it's actual it's not defined. Identifier is not defined. That's that same page I was just on. Doc type, blah blah blah. Import say hi from blank. Say hi, John. Okay, error user is not defined. And the input level for each module. Make the window. If we really need to make a window level global variable, can explicitly assign it to window and access as window user. I did try putting it in the same tag though, and it didn't seem to work either. That's how to create the module. How do we actually implement and use it, though? Okay. So let me go ahead and do this again. I think it said that scene is not part of 3. I think that's what the error was that we got before. Yeah, 3.scene is not a constructor. Should always see the file from the .build folder of Three.JS repository version hosted by cdjns. Oh. Well, this is the .build folder. We don't have to use capital 3, do we? Because we're defining what it is here, so saying this module is 3. Whoa. All kinds of stuff going on here. Okay, I was trying to do the same thing we're trying to do right now. Okay. Yeah, I'm looking to it directly, though. That's what it says to use, right? So when I went to here, though, it pulled up build 3.js instead of module. Oh, there it is, .module.js. That's probably why. Weird. That would automatically default to the other one. All right, let's load this one up and see what happens. Perspective camera, I probably typoed something on that one. Okay, I'm going to go back to create a scene. Just going to copy this. Ah, we have something. Okay. So we have go away. Refresh. So we got our square here. Alright, next up was rendering the scene, then animating the cube. If you install the code of this, blah blah blah, see green screen, let's make it green cube on the screen. Let's make it a little more interesting by rotating it. Add the following right above the render.render call. Animate function. Cube rotation x and y plus equals 1.01. Oh, up here. Okay. So cube dot rotation dot x equals. Basically, we're adding 0.01 to the rotation, x rotation on this per call. And same with the y. Cool. Oh, you can tell, yeah, it's definitely 3D. Ooh, that's kind of weird. Whoa. Smacking the pop filter around. Okay, so we got rotation. Rotation has been achieved. So what's next? That's the full code. Okay. So we have this. Okay. Now. So if I have a I guess it would be circle geometry. I'd want to be like a flat object though. So, I need this. So 3.js. Draw a circle not shaded. Circle geometry. Okay, so it is flat by default. So circle geometry is a simple shape in Euclidean. Oh God, can't say this word all the time. Euclidean. D-E-A-N. Whatever, this word. Geometry. It's used for a number of triangle segments, blah, 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 okay. So geometry material. So I guess the question is the material. Can I make a material out of an image? Materia. This is an F7. So texture, new through the texture loader, textures dot create GIF. Okay, yeah, so you can. So let's take this and actually do something with it now. So we're going to turn this to a circle geometry. We'll rename this to be, let's call it, let's say anchor point or something like that. And anchor point. So like this will be the main thing that will have other things rotating around, hopefully. Equals new circle geometry. Circle geometry. Yeah, I think it's Euclidean. I think that's how you pronounce that. And I've heard it said before, it's just I don't use that word very often. Euclidean.
Euclidean.
Yeah, Euclidean. It's a idea of how it relates visually to geometry. So like that's, you know, everything kind of like a non-Euclidean geometry is like something that where you're looking at it, it looks like a certain way, but it's actually a different way. So like if you're going like looking at a hallway, let me see. It's very hard to describe non-Euclidean geometry. Yeah, here we go, like this. Like, so for example, you see this box here, and you think you're going into an area that looks the same in terms of dimensions as where you're going to, but in reality, if you go to the side of this little archway, it actually gets smaller on the outside. So it's kind of like a TARDIS effect in a way. Bigger on the inside than it looks, or smaller on the inside than it looks. That's what non-Euclidean geometry would be like. Anyway, so circle geometry, 5 and 2. What are the two? The radius and the segments. Radius. How would that correspond to an x and y coordinate, or x and y width and height kind of thing? So width and height, radius is radius minus height over width, or under width. Okay, so width squared plus radius minus height squared equals radius squared. Quadratic in H. So solution is height equals, so it's like finding the height though, but I'm going to find the radius. Quadratic is for finding quadratic in height. We're getting into friggin' college level geometry and algebra and whatnot now. There we go. So radius is width divided by 2 plus height to the second power divided by 8 times the width. So height divided by 2 equals r times sin of whatever that is. Solved for r and okay. So find out what the height and width of this is.